All right, this is the lesson 12B video. We're going to learn about the fundamental forces. Just a reminder, those are the assignments that are due this week. And any announcements, just check that first introductory review video. The big question for today is, can you ever really touch anything? So this is the weekly plan that we have. So there's just going to be like 2 major lessons and then time to take notes, go over labs, and anything that we might be able to need, just time for that homework. And it can be subject to change depending on what order things need to be presented in, or just if time needs to be diverted to something else. And there are going to be 3 assignments due every week: a lab assignment, a homework assignment, and a notebook check, which is on that homework assignment. Now, that homework assignment also has like video codes. So there's 2 codes in each video. One's a written code on the screen, the other's a verbal code said by myself. Each code will be 3 numbers, and you need them to move on. So when you're taking notes, just write what's in green, right? You're going to need these for those notebook checks, and I try to condense everything down to where it's not too much writing. So this is the video 12B written code. I would recommend writing that down somewhere. So what are the fundamental forces of the universe, right? So they're just everything can be boiled down to these. Every interaction can be boiled down to these 4 forces. So I'm just going to list them, strongest to weakest. So the strong force, that's what holds the nucleus of an atom together. It's a strong nuclear force, right? It's the strongest force. Its range is about the width of the nucleus of an atom. So we don't interact with it. We don't feel this force because it doesn't really even make it outside of the atom, because it just holds the protons and those neutrons together. Now, the electromagnetic force is the attraction or repulsion between positive and negative particles. It's the only force that can repel. Its range is infinite. So it's the only force that can repel. Now, the weak force is responsible for radioactive decay. It has the shortest range of any force. Its range is about the 10th of width of a proton, right? So the strong force holds these protons and neutrons together. If I zoom in and I look at a proton, that weak force only goes about a 10th the width of a proton, right? So very, very small range. Now, gravity is the weakest force, right? It's the attraction of all mass, and its range is infinite. So this is the chart that we make, starting from strongest to the weakest force. Now, notice how weak gravity is. If the strong force has a strength of 1, well, gravity is 0 point followed by 38 zeros and a 6, right? That number right there. It's very, very weak. And the ranges, well, notice that only 2 of them are infinite, and the other 2, strong and the weak force, are very, very small ranges. Why does gravity hold you to the Earth? Now, the electromagnetic force does pull on you. It does pull you towards the Earth. However, the electromagnetic force also repels, because you have just about the same number of protons and electrons in your body, and the Earth has just about the same number of protons and electrons. So the attraction also balances out the repulsion. Now, gravity is only attractive. There's no repulsion to gravity. So even though it's a very, very weak force, it's the only one that's pulling you down to the Earth, because the strong and the weak force have much smaller ranges, and the electromagnetic force repels you as well. So this is a video on the fundamental forces, and it just talks about how gravity really doesn't fit. It's just that weird force that we don't really understand, and it doesn't fit on a subatomic level. This is the standard model. These are everything that we know about ordinary matter is composed of these 17 different particles, right? I like to think it's kind of sloppy that there's 17 of them, and we're still kind of working on some theoretical ones. But gravity just doesn't fit in there. There's nothing in here that like gravity just doesn't fit. So we're always trying to understand that. When I did the world's greatest physics demo, I always put that up because we can't really explain it. Now, can you ever really touch anything? So to understand that, we need to understand the inverse square law, right? So sound, light, electromagnetic, like all of these operate on what we call the inverse square law. Now notice that if I look up here, like this is the distance, the r. The distance as to like particles or magnets get closer together, notice that the strength goes up. But r can never be 0, right? Otherwise, the strength would be infinite. So let's look at what happens on like atoms when you touch something, right? So what happens is, as atoms get closer together, those electrons on the outside of the atom start to repel each other. And the closer they get, well, just like the inverse square law, that distance decreases, well, that strength increases. And they're never going to touch because r can never be zero. That distance can never be zero because otherwise the repulsion would be infinite. So when you're touching something, you're just hovering. Touch is a word that we use to describe our human condition interacting with different objects. Same thing with rough, cold, and the big question that I always get is water wet? Well, no, that's just how we use, that's just the word that we use to describe our interaction with water. Water molecules don't have the property of wet. That's just something we use to describe them. Now, this video shows why we can't really touch anything. So let's look at different, actually, I'll give you the verbal code now. The verbal code is 788. I say again, the verbal code is 788. All right, so this is the fundamental forces activity. What I wanted you to see is that anything you touch, like getting punched in the face, well, those electrons are repelling each other. Same thing as a car hitting a tree, those electrons. Now, if you're falling down or what's holding you down to the ground, that's gravity. Now, photons are part of the electromagnetic spectrum. So it's just ripples in the electromagnetic field. So photons hitting your eye, that's the electromagnetic force is responsible for that. Air vibrating as you're listening to music. All sound is the molecules getting close together, repelling, getting close to other molecules, repelling, and they vibrate because of the electromagnetic spectrum. Car coming to stop after slamming on the brakes. Well, friction is just those intermolecular forces. They're bumping, they're close to each other, and those electromagnetic repulsions are bringing it to a stop. So friction is the electromagnetic force. Pushing off the water, well, once again, the atom or the electrons in your hands are getting close to the electrons in the water, and it's pushing it out of the way. So that's the electromagnetic force. Now, some potassium goes through some radioactive decay. Well, that's due to the weak force. That's what the weak force does. It's responsible for radioactive decay. Now, the electrical impulses in your brain, that's electromagnetic field, or the electromagnetic force. Nucleons being held together in the nucleus of an atom. That's a strong force. So, which of the four fundamental forces has the largest impact on your life? Well, it's going to be the electromagnetic force. Everything you think, everything you do, everything that you are is the electromagnetic force. Gravity just holds you to the ground. The strong force holds the atoms together, and the weak force is responsible for radioactive decay. They're all important, but every interaction that we have in our life, like every experience that we have, is because of the electromagnetic force. All gravity does is hold us to the ground. All right. So those are the links for today. And just remember, as a final thought, there's too much unknown in the universe to take a break from learning. Get out there and question everything.